Welcome to the Choose SolidWorks screencast series. My name is Neil Cook, Product Marketing Manager at SolidWorks. If you're a machinery designer or make anything with thousands of parts and you're looking for a new CAD system, then you should check how easy it is to use and how easy it is to create parts, small sub-assemblies and drawings. You should also check out capabilities in sheet metal, weldments and even surfacing. But once your entire design is on screen, things can start to slow down or even stop as your computer resources are consumed. Luckily, SolidWorks has a few tricks up its sleeve that can help you get your job done, and that's what this screencast series is all about. Does your computer grind to a halt when working with thousands of parts? Does it take too long to open, save and make GA drawings? And do you have problems sharing complete designs with customers or suppliers? With SolidWorks you can work in 64-bit where the only limitation on memory is the cost. Open complete assemblies in a lightweight representation or selectively open only the parts you need, all without any previous preparation. And share extremely large designs in a very small compact form whilst protecting your intellectual property. Massive assemblies? No sweat. Most new computers these days are 64-bit, but most of us still use a 32-bit operating system, which limits the available memory to each application. Windows itself can take up to 2 GB of memory, especially if you have other documents, spreadsheets, email and web browsers open at the same time. This design from the Vermeer manufacturing company is detailed right down to the last nut and bolt to ensure clearances, center of gravity and correct bill of materials. This video is speeded up, but it takes just over a minute and around 2.5 gigs of memory to open this assembly in the 64-bit version of SolidWorks. With around 6,500 components and 1,200 unique parts, it's only a medium-sized assembly, but even so, if you don't have the available computing power, you're going to struggle. If we take a look at the level of detail in this assembly, some parts are simple, like the fasteners, and some are complex, but the important thing is that it's complete, so there's no possibility of error during manufacture. So how can you share your complete designs with colleagues, customers and suppliers who don't have the latest hardware? What do you need to do to get SolidWorks to open this assembly on a less powerful machine? Well, the answer is absolutely nothing. SolidWorks detects the number of components in the assembly and activates large assembly mode. This opens all the components lightweight and switches off the nice looking graphics like reflections and shadows. Now the exact same assembly opens in around 20 seconds with about a tenth of the memory used, and the level of detail is reduced when rotating to make it fast and interactive. Lightweight components contain all the solid geometry but not the underlying feature detail, so you can still check for interferences and assembly motion. Selecting a component highlights it in the feature tree. Selecting it a second time removes the feather from the icon and loads the complete part into memory. Now we can quite happily make any changes we want. Even though the detail of the adjacent part is not loaded, SolidWorks knows it must also load that in order to update it and maintain your design intent. But what about drawings? Well, we have the geometry of all the parts already, so making the drawing is easy. However, SolidWorks does use some clever tricks, invisible to the user, to speed things up. We can see how quick it is to lay down 4 views of this 6,500 component assembly, and moving around the drawing is also quick, as SolidWorks uses image refinement technology to reduce the amount of data on screen at any one time. Dimensions, bills of materials tables, balloons and notes can all be added to the drawing as usual, because the geometry and the information about the assembly is 100% present and correct, but without the overhead. As we pan around the drawing sheet, the accuracy of the geometry becomes apparent, especially in these detailed areas around the engine. Now what we've looked at so far is opening the complete dataset. If we only want to work on specific areas of a design, then we don't want the whole assembly open. But what if you can't remember those cryptic part numbers? Well, we can use Quick View, another time-saving tool. This opens just the graphics of the whole assembly in a jaw-dropping 5 seconds. We can then selectively open just the parts we're interested in, so we don't need to plan things ahead of time and simplify the assembly or predefine a configuration. It's easy to select individual parts and to also include the sub-assemblies to which they belong. Once we're satisfied we have everything we need, SolidWorks opens just those parts and leaves everything else hidden. What's amazing about this way of working is that even though we haven't loaded any of the parts that these components are assembled to, SolidWorks remembers how they were put together and allows us to test any moving parts, or use any of the other assembly design tools like the hole alignment check or interference detection, or in this case, check that the operator won't get his hands trapped by checking the clearance between two parts. But maybe we need to consider other components in this design view, but we didn't open them. Not a problem, we can go back to selecting the components to open just by once again showing all the hidden parts and selecting the ones we're interested in. This is a very fast and intuitive way of working, as we can easily navigate and work with large assemblies and fix design problems as they arise. Any newly added components behave exactly as you would expect. If your design is work in progress, you can use configurations to simplify the design. Configurations are used to create variations of designs, such as different sizes of fasteners, but they can also be used to simplify components and assemblies and create subsets of designs that can be opened directly. In the engine assembly, we have the default configuration with all the detail, a simplified one containing simplified versions of the frame without holes, and a configuration being used to design a new welded frame, removing the old one from view, but allowing it to be substituted back at any time. Individual components being worked on may be isolated to simply remove the visual clutter from the screen. This view can then be saved as a display state and recalled at any time. What's more, this display state can be opened directly, and none of the hidden components will be loaded into memory. Sharing complex designs with lots of unnecessary detail or designs containing sensitive intellectual property is no longer a problem. A technology called SpeedPack enables us to reduce the amount of data in a design by only including the faces or components we select. SpeedPack determines which components are internal to the design and then with a slider removes faces or components based on their size, so we could just be left with the engine block. In reality, the most important aspects of this design are the mounting points and the parts that interface with the main assembly. So we can select the individual components to be included or individual faces, particularly if the faces belong to a complex component. Everything else in the assembly is not needed. It just needs to be there to represent the entire assembly. So there's our SpeedPack configuration. Doesn't look any different? Well, it does when you move the mouse over the assembly. The faces that don't really exist are removed, so we can clearly see which faces have been included and can be referenced in the top-level assembly. Notice also that the assembly file has no parts, making it extremely compact, easy to email, and impossible to reverse engineer. Now let's open the main assembly, this time using the advanced option. This gives us many extra capabilities, like opening the entire assembly with everything suppressed, or creating a brand new configuration on the fly. Here we'll open the top-level assembly, but substitute every subassembly that already contains a SpeedPack configuration. Every SpeedPack subassembly is empty, and if we move the mouse over the main assembly, we'll see that it only contains a handful of components. Finally, what about creating drawings of SpeedPack assemblies and opening drawings containing lots of sheets? Drawings also have a quick view option where we only need to load the sheets we want to work on. That way, we don't need to load unnecessary models that only appear on other sheets. Hovering the mouse over the drawing sheet tabs gives us a nice big thumbnail view. When we activate a specific sheet, it's still in quick view mode, so we can't actually edit any of the details. To do that, simply load the sheet. The SpeedPack assembly we created can be detailed just as easily as the full assembly drawing we created earlier. Just add the 4 views in the exact same way. Massive assemblies? No sweat. I hope you've enjoyed this quick look at how SolidWorks handles large assemblies. We strive to deliver simple but effective tools to help you focus on making your designs, not fighting with the CAD system, and to make it an enjoyable experience too. We want you to look forward to using the product at the start of the day and value its role at the end of the day. For more information and to see other screencasts in this series, please go to www.solidworks.com/choose or contact your local SolidWorks reseller. My name is Neil Cook. Thank you for watching.